So, the last thing we're going to talk about for the topics for the midterm, and if you look on the discussion board, it should be problem number 26, is going to be long division. Long division and synthetic. Now, why is this even important? Well, the issue that we have is, or the things that we know is that, hey, let p of x be a polynomial. I know that if p of x is a polynomial, then if I were to tell you if p of, give me a value, let's call this value c equals 0, then we can say that x minus c equals, no, x minus c is a factor. We can say that by our logical statements that we have from last section. So x minus c is a factor. And I encourage you to remember what a factor actually is of p of x. A factor is a component of a product that if I have a factor times all the other factors, I should get my product. What that means is that if I have p of x and I were to divide x minus c, and then it should have no remainders. It should divide out cleanly. Same with, hey, 2 is a factor of 6 because 6 divided by 2 is 3. There's no decimals involved. And that's how we're going to find out what our other factors are. It's that idea that, hey, if I have a factor, then I know it divides cleanly, and I can probably get my other factors from the first factor itself. So, we got to come with a little statement. So, if p of x, and let's call this one d of x, are polynomials with d of x not equal to 0. Can't be 0. And why do I say it cannot be 0? Well, there's gonna exist, or I'm not gonna use that symbol, that's too much of a symbol. There exists, why did I use it again? I'm so used to using these symbols. There exists a unique q of x such that qx and r of x such that I can have my polynomial divided by my division polynomial. Let's call this a divisor, d for divisor. And that's going to be equal to exactly q of x, my quotient polynomial, plus some remainder polynomial. That remainder can be written as the remainder over my divisor. Boom. Okay. You might see it written differently. You also might see it as some of you guys might see it as p of x equals q of x times d of x plus your remainder. You can also see it that way. Either or makes sense. I'm just going to let you know that the p of x is called your dividend. This is what is being divided. Now, d is called a divisor. This is what you're dividing by. Q of x is your quotient. That's the answer you get once you divide the terms out. And r of x is your remaining pieces. Remainder. These terminologies are important, so you do need to know them. Now, we need to know how to divide these polynomial expressions out. So let's go with long division. So you guys have worked with long division, but only for real numbers. Now, even though I say real numbers, you've only worked with them with, I guess, numerical expressions. That's the better terminology. But you haven't worked with long division with actual expressions. If I had variables, if I had terms, if I had some other stuff outside of just constants. So let's take the dividend. Let's let d of x equal oops, not let's not, sorry, let p of x, let p of x equal, let's let this be equal to 6x squared minus 26x plus 12. And then let's suppose I want to divide that by, let's let the divisor be x minus 4. Find q of x and r of x. Find the quotient and the associating remainder. So I have to divide this out. Now, when doing long division, always, there's a little remark, always have p of x in descending order with all exponents. So that means, you know, I need to have, if this highest degree is 2, I need this to be the degree of 1, and this needs to be a degree of 0. So I need to go in decreasing order with the exponents. And even if I'm missing a term, let's suppose that this was 6x squared plus 12x, or plus 12, I have to have a term with the first power. So I would have to say plus 0x to the 0x to the first power. So I'll give you examples on that later on. So first, let's actually work this out. When you're dividing this out, our dividend goes inside our actual division symbol rule. Boom, looks like this. Our dividend will go inside. Our dividend is 6x squared. It is in descending order, so we're in the clear. Minus 26x. And then plus 12. Boom. And I'm dividing that by x minus 4. And then how do I divide? Well, long division states that whatever you have here, you need to divide it to over here. Now, you can't divide one term by two term, or one term by two terms, two term by one term. You need to have, you know, the number of terms need to be similar to each other. So I have to divide x minus 4 into this guy. But that's a problem because they don't go out nicely. So what you're going to do is you're going to get the highest degree right here. It's x. And you're going to divide it by the highest degree term. Boom. So you need to divide the highest term by the highest term first. All right. So 6x squared divided by x. Well, that's just 6x. That's just 6x. Once you have that quotient, that piece of your quotient, now you're going to actually distribute this out, because remember, in long division, we multiply. However, I have other pieces besides just one term. So I need to multiply both terms by 6x. Multiply them both out. I should get 6x squared minus 24x. Let me just see if this is right. Yep, minus 24x. Now, I like to use parentheses so I don't mess up. Now, in long division, it says that once you multiply those numbers out, the quotient with the actual divisor, that means you have to subtract them out to your dividend. So if I'm subtracting it out to my dividend, this is why I use parentheses. This first term should always cancel out. It should always cancel. If you didn't cancel out correctly, then that means you did something wrong. Now, this is negative 26 minus 24x. So technically speaking, this is plus because I'm subtracting a negative, so I'm adding it actually. So negative 26 plus 24x, that's going to be negative 2x. Boom. Well, now we have one term for our leftover piece, but notice that our divisor has two terms, which means I need to drop another term down. Boom. I need to drop that term down. Now I have two terms and two terms. I can work with that, thankfully. Well, now I can do the same process over again. Hey, now on this guy, get my highest term degree, my leading term. I got to divide that by the leading term here. Negative 2x divided by x. That should give me minus 2. Negative 2. Now I can distribute this over. Once I distribute this over, I get negative 2x. And then negative 2 times negative 4, that's going to be plus 8. And remember, I am subtracting. I use parentheses so I don't mess up. If I subtract these out, these better cancel out completely. Negative 2 minus negative 2x is negative 2x plus 2x. So they're off. 12 minus positive 8, that's going to be 4. Now notice that I have a single term. There's two terms here, but I have nothing that I can drop down. So we say now our remainder is, this is plus our remainder, 4 over, and then we're going to divide that by our divisor. Your remainder is always going to be what you're left over with divided by your divisor. It's going to be a ratio of your divisors. So this piece is called, this is your dividend. I mean, that's not your dividend. This is your quotient. Quotient. And then this piece is your remainder. Good. Now, they don't divide cleanly. If they do not divide cleanly, they are not factors. All right? If I say 5 divided by 3, we get a decimal. That does not divide out cleanly. 3 is not a factor of 5. That's the idea that we're going with. All right, so now we move to another problem. Let's try another one out. That's one example. Now let's go to an idea called synthetic, or let's do another one actually. I want to do another one. Let's say I want to calculate x cubed, or not even calculate, determine if x cubed plus 3 has a factor of x minus 1. Determine if x minus 1 is a factor of x cubed plus 3. All right, so let's start that out. Now, we got to draw our little division symbol. Oops, sorry about that. Power's going out because of the electricity. But our little division symbol over here. Now, the problem with this is in descending order, but we're missing some terms. You have to list out all the terms. So this should be x cubed, but I don't have an x squared term. So I have to put down plus 0x squared plus 0x to the first power, and then plus 3. You have to list all of them. And then x minus 1 goes over here. Now I can actually work with this. So get my leading terms, boom, x and x cubed, divide them out. I get x squared. Now that I divide them out, I need to multiply. I need to multiply this out. I need to distribute that out. So once I multiplied it out, I get x cubed minus x squared. Use parentheses, they should be subtracting. These guys will always cancel out, boom, if you do it right. And then 0x squared minus negative x squared. Well, that's negative of a negative, so that turns to positive. So we have x squared. Well, this is still two terms, and this is one term, so I need to drop another term down. You drop this guy, so plus 0x. These are like placeholders, so you can actually work with your mathematics. It's good to have these placeholders out. Oh, and my power actually just went out. Hopefully that didn't disrupt the video, but we'll see. My power actually went out there. But now I can actually divide them out again. So after I get two terms and two terms, I can divide the leading terms out. X squared divided by x, that's just going to be plus x. Distribute this guy out. And I should get x squared minus x. Subtract these out. I get, what is that? Negative of negative is a positive. So this turns to plus x. And then lastly, drop that last plus 3 down. Now, this is a factor 1, because x divided by x is 1. If I multiply and distribute this guy out, I get x minus negative 1. Is it x minus negative 1? Yep. X minus 1. And I'm subtracting these. These guys should cancel out. 3 minus negative 1, that's the same thing as 3 plus 4, so this is still plus 4. Boom. That means we have a remainder plus 4 over x minus 1. So we say x minus 1 is not a factor of x cubed plus 1. It is not a factor. It does not divide out evenly. All right, so that covers that for the long division. Now we talk about synthetic division. Synthetic division. Now I'm going to make a key point. It works for divisors in the form of x minus c. So if your divisor is linear, if you're dividing only by x minus some constant, you can use synthetic division. If it's not, then I'd be very careful about trying to use synthetic division. There are still ways you can, but we're not going to talk about that because it gets very messy. I would suggest you just do long division if that was the case. So let's say we're going to do 2x cubed minus 7x squared plus 5 divided by x minus 3. Now, it's hard for me to factor this out and then see what cancels out. So I'm going to do synthetic division or long division, whatever you prefer. Now, how do you do synthetic division? Well, first, you need to have p of x in descending order again. It has to be in descending order, and you have to have placeholders for each power. And the way you're going to set this up is that, hey, we need to set up our values, our coefficients of each placeholders. Each of these placeholders, we're going to actually account them, the coefficients. So I'm going to write them all out. So we're going to have a placeholder of 2, a coefficient of 2. We're going to have a coefficient of -7. Notice that I don't have an x to the first power. That means I need to have a placeholder for that, which is going to be 0. And then I need the last coefficient, which is +5. So it's going to be 5. Boom. Great. Now, what you're going to be doing here, since you're dividing by x minus 3, you're going to have to put down whatever the root is supposed to be, the 0. So in this case, it's going to be the value 3, because 3 minus 3 is 0. So we're going to put that value there. If it's x minus c, we're going to put c in here. That's the idea. Okay, so now how do you do synthetic division? Well, the first process requires you to drop down that 2. That's the first step. So when we divide this down and everything, that'll be the first coefficient of our leading term. It will always be the same one as your original. Now, once you have that, you're actually going to multiply, boom, multiply 3 times 2, which is 6. And then you're going to add these together now. These are all additions. So -7 plus 6, that's going to be -1. And then you're going to multiply that guy out. -3 times 1, it's -3. You're going to add that together, you get -3. Now you got to do -3 times 3, which is going to give you -9. -9 plus 5 is going to give you -4. So now that you have this, you can re-express your polynomial. But since we divided by x to the first power, from x cubed, we're going to go down 1 power each of them. So instead, this is going to be now 2x. Originally, it was x cubed, so I'm going down 1 power. 2x squared minus 1x minus 3. I'm just going down a power every single time. And now, this is a constant, though. So the last part has to be a remainder. So I'm going to write remainder -4. And you can write this as remainder -4 over x minus 3. So remainder -4. So what does this mean? Well, that means that p, if I have my polynomial, and I threw inside 3, that's going to give me -4. It will not give me 0 because it's not a factor. Remember, if it was equal to 0, if p of c, then we can say that c is a 0 and x minus c is a factor. But because we have our remainder, because we have this remainder, if I get my polynomial and evaluate it at that value that I use here, that thing that I thought was supposed to be divisible or 0, and if it turns out not to be 0, it's not a factor. In this case, it's -4, so it is not a factor. Not a factor. So that's how you do synthetic division. Now we relate to some powerful theorems that I've already kind of, I foreshadowed in a sense. So the first theorem is, so these are theorems. These are very important theorems you need to know. The first theorem that we're going to say is if polynomial p of x is divided by x minus c, then remainder is p of c. The remainder is the value p of c, which means that if it's equal to 0, you have 0 remainder, so it is a factor. If it's not 0, it is not a remainder, therefore not a factor. That's theorem 1. That's one theorem. Another theorem we have that's very powerful is that c is a 0 if and only if, IFF means if and only if, x minus c is a factor of p of x. That's why we call it a 0, by the way. So, i.e., p of c equals 0. So, let's do an example using these powerful theorems. These are very important theorems, and it does relate to number 26 on that discussion board. So, let's take example p of x equals x cubed minus 7x plus 6. Factor fully if p of 1 equals 0. So it's hard to factor this guy fully. It's hard. If it was x squared, I could treat it like a trinomial and say it's x minus 6 times x minus 7, but it's x cubed, so I can't do that. I also can't find the GCF because none of these three terms have something in common. I also can't group it because there's only 3 terms and not 4 terms. So I need some way to deal with this. And the way you want to deal with this, if I give you this information, we know x minus c, or in this case 1, is a factor of x cubed minus 7x plus 6. This means if I divide it out, I get no remainders. So let's divide it out now. X cubed minus 7x. I think is it plus 6 or minus 6? Plus 6. And we're going to divide that out by x minus 1. Okay? So there's a problem with this. Not all the terms are listed. So I need to have these placeholders. I can't do it without placeholders. So we're going to put plus 0x squared, or plus 0x squared minus 7x. And then I could do the plus 6. That's more like it. So now I have 4 terms. Now I can actually work with this. So the leading terms, x cubed and x, divide them out. I get x squared. Now I gotta distribute this guy out again. Long division states that. You could do synthetic division. I think synthetic division might be faster here, but I just want to do it with long division so you guys can get the idea. Boom. Now I get x cubed minus x squared. Subtract these off. These should cancel out. And then subtract the negative. That's going to be positive x squared. And then this is 1 term, 2 terms. So I need to drop a term down. Now I can divide it out. X squared divided by x right here. Well, that's just going to be plus x. Now I distribute this guy out. So now I get x squared minus x. And I'm subtracting it as always. I'm always subtracting it. Don't forget that. People will make a mistake. Boom. So once I subtract this out, I get, well, these guys should always cancel out. Negative 7 minus negative x, which is the same thing as plus x, which is the same thing as minus 6x. Well, one term, two terms, I got to drop a term down. Plus 6. Now, divide that out. If I divide it out, I get negative 6. Negative 6x divided by x is negative 6. So, multiply this out, distribute it out now. I get negative 6x plus 6. Subtract that out. If I do this, this cancels out. 6 minus positive 6, which is going to give me 0. My remainder is 0. Remainder 0. So remainder 0, which you don't even need to put there. You don't even need to say anything. So if I divide it out, I should get, technically speaking, I can write this as x cubed minus 7x plus 6. This is the same thing as saying x minus your divisor, minus 1, times whatever your quotient is, x squared, and then let's look above, plus x minus 6. They're the exact same thing. I factored it out, technically speaking. It factors out for you if the remainder is 0 plus 6. I think it's plus 6, right? No, it's minus 6. Boom. Now, I almost factored it fully. So look, I turned this into the factor, because it's a factor because it divides evenly, and it's going to be times whatever the quotient is. However, now I can factor this guy out. If I factor this guy out, this still stays the same. This becomes x minus or plus 6. Oops, is it minus 6? No, I'm thinking wrong. It's plus 3, x minus 2. So I've done a few things. I was able to factor this guy out fully, p of x. I was able to factor it out fully without using those crazy factoring methods. Rather, I just use long division to help me factor it out. And I have a few statements I can say. I can say that p of 1, comma, or p of 1 equals 0. I can say p of negative 3 equals 0. And I can say p of 2 equals 0. I can say all these three because they are factors. If I plug them into my function, if I use them as inputs, the output should be 0. So that's a very important thing right there. And it will lead into later on when we start sketching them and whatnot. So that ends off today. That's long division, and that is synthetic division. I will catch you guys later. Take care.